So we're going to shift away from absolute values. Now we're going to look at reciprocals. Reciprocals are essentially flipping of numbers or functions. So if we have the function f of x equals 2x plus 5, the reciprocal of that would be y equals 1 over 2x plus 5. Question B, the equation of the vertical asymptote. Asymptotes are places where graphs can't exist. Because we are taking 1 and dividing it by 2x plus 5, there is a situation in which division is not possible, and that's dividing by 0. We can't take 1 and divide it by 0. We can't take anything and divide it by 0. If you even try that in your calculator, you'll get some kind of error message if you try to divide by 0. What that has an effect on the graphs, it creates what's called an asymptote. Think of it as playing with your little brother or sister, putting your finger as close as you can to their nose and saying, I'm not touching you, I'm not touching you. That's essentially what an asymptote is. An asymptote is just not touching the graph. Why do we have to find it mathematically? Why can't we just look at the graph? It's because of the way that the calculators function. They don't show asymptotes well. So if we know where the asymptote is, we can interpret what the calculator shows us. To find the asymptote, we take the bottom of the reciprocal, so that would be 2x plus 5, and we need to find where it equals 0. Simple solving the equation, take the 5 to the other side, and divide by 2. We get an asymptote at x equals negative 2.5. C, graph this out. I want a graph of the original function and the reciprocal. We'll do those separately just to make it look a little nicer. So original function was 2x plus 5. We'll graph that, and we'll sketch it out. Looks about like that. Second graph we'll look at is the reciprocal. To do that, we'll do 1 over 2x plus 5, but we need to tell the calculator that the 2x plus 5 is all contained in the denominator of the fraction, so we'll do 1 over bracket 2x plus 5. We'll graph it out, and we get what looks to be one continual piece. However, it's not. We know that we have an asymptote at negative 2.5. That vertical line that extends for a little over half the screen is the asymptote. As I said before, the calculator is not good at showing asymptotes. So if we know that there's an asymptote at negative 2.5, we can draw that on. The way we show an asymptote is with a dotted line. The rest of the graph, we have one branch like that, and another branch like that.